All right, good morning. This is Ms. Trangle. This is your video for 2-3, which is on postulates and diagrams. I think it will feel nice and refreshing after 2-2. And I'm going to really try for one video today. So set up your date and topic in the your date and title and topic in the upper right hand corner. You'll need to fill in the date. Then you're going to write your essential question or EQ. What are the 7 postulates about points, lines, and planes, and how are they used in geometry? So I'm still getting one letter cut off, but it's definitely better than half the video here. And then we're on Learning Target 2C. I can identify postulates using diagrams and can sketch and interpret diagrams. So if you need to pause the video, please do so. I'm going to move on so I can fit this in one video. All right, and then here are the postulates. I did put this, if you have a printer and you want to print these out, I did put this in Canvas. If you want to do notability for today, something like that, or if you want to write them down because that's better for remembering, it's up to you. So what are the 7 postulates about points, lines, and planes is our question. And then here are our 7 postulates. I'll briefly read them, okay? So 2-1 is called the 2-point postulate. It says if you have 2 points, like A and B, there's one line that goes through 2 points. Okay? Then 2-2 is the line postulate. A line contains at least 2 points. Okay? A line contains at least 2 points. 2-3. The line intersection postulate. If 2 lines intersect, so you have line N and you have line M, so if those 2 lines intersect, they intersect at exactly one place. That is what that is saying. All right, next we have 2-4, the 3-point postulate. Through any 3 non-collinear points, so 3 points not on the same line, there's one plane that they will all be on. So D, E, R, and F, okay, are non-collinear points. There would be one plane. All right, 2-5, the plane point postulate. A plane contains at least 3 non-collinear points. So we might have a point on a line, a point off the line, and we might have a line segment, something like that. Just an example. All right, 2-6, the plane line postulate. If 2 points lie in a plane, then the line containing them is also in the plane. So in this example, D and E are on the same plane. So line R is on the plane as well. Okay, and the last one, 2-7, plane intersection postulate. If you have 2 planes, they intersect and form a line on their intersection. Okay, so if you need to pause the video or zoom in or go back, here are your 7 postulates. So that looks to me like 2-3, the line intersection postulate. If 2 lines intersect, so 2-3, you can find that one. Should be 2-7 down here, the plane intersection postulate, 2-7, the plane. So the plane point postulate is 2-5. A plane contains at least 3 non-collinear points. So we need to name 3 plane line postulate. 2-6. If 2 points lie in a plane, then the line containing them is also. All right, example problems. So pause the video, set up your examples, set up your diagrams. All you're going to do is state the postulate 2-1, 2-2, illustrated by the diagrams. So part A says if 2 lines are intersecting, then they intersect, and it's red here, they intersect at one point. So I'm just going to go back and look for 2 lines intersect at one line. Intersection postulate. Okay. Part B, if two planes intersect, then they intersect at one, and they intersect and they form one line. So see intersection postulate. Okay, so pause the video if you need more time. I'm going to go on to example collinear point postulate plane. All right, example 2, use the diagram to write examples of the plane point postulate and the plane line postulate. So let's start with the plane point postulate, and we'll do that right over here. So let's go back and refresh plane point postulates. Okay, so let's name 3 non-collinear points. How about B, A, and C? So B, A, and C are on plane P. And they are not all collinear. All right, so that would be my answer for that one. All right, then we need the plane line postulate. So let's go look at the plane. So let's look for 2 points. I see B and A. So B and A are on plane C. Okay, so that means line N is also on plane P, or plane C. Or we can call it plane P. Okay, so B and A, points B and A are on plane P. Yeah, it's plane P. So line N is also on plane P. Okay. All right. Next question, number 3. Sketch a diagram showing line TV. So let's do TV, line TV. So here's T, here's V. I will make a line with 2 arrows going forever in either direction, intersecting line segment PQ at point W. So here's W, and here is line segment PQ, so that TW, so TW is this part right here, is congruent to, that's a symbol for congruent. So we'll go ahead and make the congruent symbols to WV. Okay, so I have line TV in red that goes on forever. I have line segment PQ in purple. They intersect at point W. And I have marked that TW and WV are congruent. All right, example 4, last example. So the question, I'll read it because it's a little cut off. How can you tell if a line is perpendicular to a plane? And if you wanted to, you might want to pause the video so you can kind of set this up. There's basically like a for A, B, C, D, and E, and you're using this diagram. So which of the following statements cannot be assumed? So we're going to put like true or false. So points, part A, points A, B, and F are collinear. So let's find those points. Here's A, here's B, here's F. Those are collinear. They are on the same line. So I'm going to go ahead and say true. Okay, then I'm going to erase that so I can see my diagram. Part B, points E, B, and D. So let's find those. E, B, and D are collinear. That is false. E is, none of them are on the same line. So false. Okay. Part C, line AB. So here's AB. Is perpendicular to plane S. And let's see, plane S is here. And yes, that is true because there is that little perpendicular right angle mark. So true, yes. We have to have that symbol to assume that it's perpendicular. All right, CD. So CD is right here. Is CD perpendicular to plane T? I'm going to say no. We don't know that because there isn't the little marking. So I'm going to go ahead and say false. Okay, and last one. AF. Let's find line AF. AF intersects BC. BC at point B. Yes, that is true. Okay, so just make sure you're looking for that perpendicular mark to assume that they're perpendicular. All right, so the summary might take you a little while. The examples were pretty short. Summarize the 7 postulates. So I do want a summary. It doesn't need to be a novel. I did 2, 3 for you just as an example. So you kind of have 6 left to do. So postulate 2, 3 states if 2 lines intersect, then they intersect in one place only. All right, the homework 1 and 3 through 23 on page 87 will be up on the Big Ideas app for you. So email me with any questions. Otherwise, have a great day.